Using L'Hopital rule, we can derive these three theorems and they are very useful. Suppose first of all you have to find, say, limit x tends to 0, 1 plus x to the power 1 by x, that is 1 plus x to the power 1 by x, limit x tends to 0. Now you see this is of the form when x tends to 0, this is 1 to the power infinity. So we should make use of the exponential or the natural logarithm. So I can write it like this: limit x tends to 0, 1 plus x to the power 1 by x. Using exponential, I can write this thing as e to the power ln 1 plus x divided by x, because you see e to the power ln 1 plus x whole by x, this is same as 1 plus x to the power 1 by x. This is same because this 1 by x is here, so this will go and this will become 1 plus x to the power 1 by x, and e to the power ln anything is same as this. So now since this exponential is a continuous function, what I will do, this limit I can take above, so this will become e to the power, now limit of this thing ln 1 plus x by x. Now this I can find using L'Hopital rule, because this is of the form 0 by 0, because you have to find, you see here it is limit x tending to 0, so this will become 0 and this is 0. So when I differentiate, I will get 1 by 1 plus x and this x will become 1. Now this limit of this x tending to 0 is 1, so the whole limit is e to the power 1 is equal to e. So you remember, this is limit 1 x tends to 0, 1 plus x to the power 1 by x is e. This is a very important formula and it has got several applications. Similarly, you can derive this also, because it's exactly same. Here you see x was tending to 0, so x was like this. Here instead of x we have written 1 by x, so this has become x tending to plus infinity, and in this case also it is x tending to minus infinity. So whether x is tending to plus infinity or x is tending to minus infinity, this 1 by x will go to 0. So all these three formulae are different variation of the same thing, but even then I can derive it. Suppose I have to derive this thing, limit x tending to plus infinity 1 plus 1 by x power x, then this is equal to e. Now this limit is of indeterminate form 1 to the power infinity. Let fx is equal to this thing, then ln fx will be x time ln 1 plus 1 by x. Now this implies that limit x tends to infinity ln fx. Now when I have to find limit of this thing, it will be ln 1 plus 1 by x. Now this x was there, so I will write it in 1 by x, so that this whole thing is now of the form, when this x tends to infinity, this is of the form 0 by 0, because 1 by x will be 0, so ln 1 is 0 and this 1 by x is anyway 0. Now you can do simple L'Hopital rule, differentiate this, then you will get something, then minus x, ultimately you will reach here 1. So implies that limit x tends to infinity ln fx is 1. Now this ln is a continuous function, so I can write limit x tending to infinity fx will be e to the power 1, that is e. Similarly you can derive for minus also. In this case we were having 1 plus 1 by x to the power x. Suppose instead of 1 by x you are having, say, r by x, and then you have to find limit x tending to infinity. Then what you can do, I will add here 1 plus r by x. Since this is r by x, I have to make here also 1 r, so I will write it as x by r whole to the power r. Now this thing, so as x tends to infinity, this whole thing will be e, and this is to the power r, so the answer will be e to the power r. So whenever you have an r here, this will become e to the power r.